Okay, so here's our vocab for solving two-step inequalities. And this is the last of the vocab in this section. First off, you've seen inequalities before. These are the stuff where I use the greater than, the less than. Now, I don't know if you've seen this part before where I have less than or equals, greater than or equals, and then not equals. So it's anything that indicates that something isn't equal. Now, you do have to learn the names of them, right? You have to learn the names of less than, greater than, less than or equal, greater than or equal, and not equal. We might say something like this, and this is what you're going to have to solve here. We might have to say that x is less than 5, right? That one doesn't take a lot of solving per se, but what it does is you're going to have to graph these. Let me kind of give you an idea what that looks like. You guys all know what a number line looks like. So I have a number line like this, and if I have 3, 4, 5, 6, and I say x is less than 5. Something else I have to show you is if I say it's less than 5, we use what's called an open circle. So like this, at 5, because it doesn't actually include 5. And then I draw an arrow pointing to the less than, so everything is less than 5. That's the solution to this. So like negative 500 billion, right, that works. Negative 4, that works. Negative 4.9999999, that works. Now the difference is, if I gave you something like this, and I said that x is greater than or equal to 2. Now, here's the thing. Put in a number line, right? And we'll have 1, 2, 3, 4. Now, greater than, I know you all know, is bigger than 2, right? So 3, 4, 5, 6, whatever. But because I included the equals part, and again, that's this little underlined part here, that means that when you graph it, you're going to put a dot filled in at 2, because 2 is included, and then an arrow heading to the right because it's all greater than stuff. So again, the difference here, if I have no equals part, so there's no line under here, the dot is open. It's an open circle, and it's everything, going the direction of greater than or less than. But if I have that equals part, it means I have to fill in the dot when I put it on the number line. So it's not just x is 2 and everything bigger. Or here, x isn't actually 5, but it's everything smaller than 5. Okay? So to come back to those names, again, this is less than, this is greater than, this is greater than or equal to, less than or equal to, and this is not equal to, so it's like not that at all. Now, like with anything, we're going to have properties, and properties have names, and you have to learn the names of the properties. I know how much you love that. For every a, b, and c in the set of real numbers, and we know what real numbers are, right? We've talked about those. Pretty much every number we've talked about. If a is greater than b, and I add some other number c to it, then it's still greater than. Likewise, if a is less than b, so again, two numbers, and I add c to them that are real numbers, it doesn't change. It's still less than. So it's just like real equations. When we add or subtract something to one side, it doesn't change anything. For instance, now watch this. If I say that x minus 3, right, is less than 5, and I go ahead and add 3 to both sides, x is still less than, in this case it's going to be 8. And that means I could have gone back here and plugged an 8 in, right? 8 minus 3, that's less than 5. But again, anything less than 8, not actually 8 itself, is the idea there. So if I have that rule for addition, I have it for subtraction too. That means no matter what the two sides are, if a is bigger than b, and I subtract c, again some other real number from both sides, it doesn't change. Likewise, if it's less than, it stays less than no matter what I subtract from both sides. I'm not sure why they have to bother having a separate property for subtraction, property of inequality, because you could just like think about adding the negative, it would be the same thing. But anyway, works just like equations. So if I say x is less than 2, and I subtract 1 from both sides, right, that means x minus 1 is less than 1. And if I think about plugging that 2 back in, right, we can see that that's going to still work down here. So subtraction property of inequalities. Okay, so I need you to tune in here. I'm going to go kind of slow. Addition and subtraction, when we add and subtract the same thing to both sides with inequalities, nothing changes. That's not true when we talk about multiplication property of inequalities. So let's start out. It says for all A, whoops, didn't mean to do that. Thought I had my laser pointer. For all A, B, and C in the set of real numbers, right? So these are real numbers, A, B, and C. I don't know what they are. Could be 5, 6, 7, whatever. When C is positive, so when I multiply both sides by a positive number, if it's less than, it stays less than. If it's greater than, it stays greater than. Okay? So again, if I multiply both sides by a positive number, that's this C represents, nothing changes. But, if that C is negative, I have to flip the inequality when I multiply or divide by that negative. So here, if I say some number A is less than some number B, and I multiply by a negative C, right? So some negative C, could be negative 2, whatever. You notice how it flips, boom, boom, right? So if it's greater than, it becomes less than. Again, that's only when I multiply or divide by a negative. I know it says multiplication here, and I'm going to give you a division property of inequality, but it's the same rules. I know that seems strange, right? So my example, right? So let's say I say that x is less than 2. And for some odd reason when I'm solving, I multiply both sides by negative 3. So negative 3 times x, right? And we say negative 2 times negative 3, right? When I do that, this becomes negative 3x, and this becomes negative 6. I have to flip the inequality. Did you catch that? This flipped around when I multiplied by a negative, right? It flipped the inequality sign. That's what we're talking about here. And I'm going to do some examples at the end of solutions with these, and you're going to have some problems anyway that you're going to have to work. So it doesn't really work any different than regular, like equations, except you got to think about this one extra thing. Now, as I promised, we had a multiplication property of inequality. We have a division property of inequality. The rules are exactly the same as multiplication. So again, A, B, and C are real numbers. If that C that I'm going to multiply both sides on is positive, then nothing changes. Less than stays less than. Greater than stays greater than. But if that C I'm using to multiply is a negative number, right? Less than becomes greater than, and greater than becomes less than. So I'm going to show you one on the next page here. So my example is going to be, I want to solve this, right? Negative 2x is less than or equal to 8. You guys all know if this was an equal sign that you would have to divide both sides by negative 2. Well, guess what? Same thing. So I'm going to divide both sides by negative 2. As soon as I do that, I'm going to flip this thing. Boom, boom, right? These go away. X becomes greater than or equal to negative 4, because 8 divided by negative 2 is negative 4. Okay? So that's the difference. If you multiply or divide by a negative when you're solving, you have to flip the inequality symbol. That's all there is to it. Now, if I thought about graphing the solution, which you're going to have to do, and I'll kind of give you a precursor to this, right? So x is greater than or equal to negative 4, so I could say negative 3. Oops, no, I couldn't. It won't fit. I could say negative 5, negative 4, negative 3, negative 2. And if it's greater than or equal to negative 4, remember that means, and we'll do some examples like this, but it means I fill in the dot because I have that equals part here. And greater than goes this way. That's where numbers get bigger. That's the kind of thing we're going to be doing in this section.